Good afternoon, everyone. My name is Sina. I'm currently a postdoctoral fellow at the University of the Free State, and I will be presenting our research on the response of bad gills to habitat loss and fragmentation in macadamia orchids today. So macadamias are currently one of the most expensive nuts in the world at nearly twice the price of almonds. So like avocados, they now have the nickname of the green gold. In 2020, South Africa was the largest producer of macadamia nuts, with over 48,000 tons. And macadamias have been one of the fastest growing tree crop industries in the country over the last decade. South African macadamia orchids cover approximately 41,000 hectares, of which around 6,000 hectares were planted in 2019 alone. This expansion is set to continue until 2030. As you can imagine, the ongoing expansion of macadamia orchids also leads to landscape management challenges. Monocultures, the excessive use of insecticides, and habitat loss at the local and landscape scale are associated with the loss of predatory insects and wild pollinators, but also with the loss of natural enemies of crop pests such as birds and bats. The response of bad gills to this land use change is what the study we are presenting today is all about. I used Google Earth historical imagery of one of our study sites to give you an impression of how fast such land use change from semi-natural habitat to macadamia orchids can happen. So you can see here the farm had a lot of semi-natural and natural habitat still. That was in 2006. Then 8 years later, in 2014, a macadamia orchid was planted. And now last year, it is in full production. There is very little natural or semi-natural vegetation left. Our study took place in the Zoutpansberg mountain range of South Africa's northernmost province Limpopo, which is located close to the borders of Botswana, Zimbabwe and Mozambique. The sampling of the macadamia orchids took place in Levubu, one of South Africa's largest and oldest macadamia growing areas, and in the Levundo Private Nature Reserve, which is in about 70 kilometers linear distance from the macadamia orchids. Both areas are on the southern slope of the Zoutpansberg Mountains and therefore similar in their climate, but also in their natural habitat types, which are part of the subtropical savanna biome. So we did two comparisons. One was a within-orchid comparison, where we used passive acoustic monitoring to assess the influence of different orchard edges on bat activity and diversity in a paired design over two macadamia growing seasons. We surveyed one natural as well as one human-modified habitat edge per farm on 6 farms, resulting in 12 sites, which we sampled from 2015 to 2017 with SM2 bat detectors. For explanation, human-modified edges included continuous crops of macadamias or other orchards such as avocado and pecan, some disrupted by roads, and natural edges consisted of macadamia trees bordering patches of natural vegetation, which are dense corridors of natural bush between 100 and 200 meters broad and up to 20 hectares in size. To assess differences in insectivorous bat activity, diversity, and species richness between a more natural land use type, the nature reserve, and the intensively managed macadamia orchids, we again used passive acoustic monitoring for 2 consecutive nights, this time with SM4 bat detectors. We recorded at 6 sites in the nature reserve in November and December 2019, and at 9 sites in the Levubu macadamia orchids in November 2019. So to summarize, we did passive acoustic monitoring. We used SM4 or SM2 bat detectors from Wildlife Acoustics. We always recorded 2 consecutive nights for 12 hours each. We did an orchard edge comparison in 2015 to 2017, where we recorded 336 detector nights. And then we did a nature reserve and orchard comparison in late 2019, where we recorded 47 and 18 detector nights each. We identified all call sequences manually to species level, using analog after converting them to zero-crossing files with Kaleidoscope. Each bat species was furthermore assigned to a foraging guild as being either clutter feeders, clutter edge feeders, or open-air feeders. So for explanation, bats that depend on dense vegetation, clutter-feeding bat species, are known to be especially sensitive as they rely on closed vegetation structures for feeding and navigation. Clutter edge feeding species likewise depend on forest edges or linear landscape features. Open-air feeding species, on the other hand, are known to be more tolerant to human disturbances. They are reported to hunt under streetlights, roost in houses, and are possibly less affected by changes in vegetation, as they generally hunt in mid-air above the canopy. So the identified bat calls were converted to the Miller's Index, accounting for species-specific activity patterns and other biases in recording, for example, if we put our bat detector accidentally close to a roost. By counting the number of active minutes per species rather than the number of bat passes. We then used R statistics for all further analysis. So between 2015 and 2017, the passive monitoring and conversion to Miller's Index resulted in over 43,000 active minutes recorded over 265 nights. We also identified a total of 25 distinct bat species during that time. In 2019, during 47 sampling nights in the nature reserve, we recorded a total of 15,000 active minutes. In the same year, in the macadamia orchards, a total of 1,800 active minutes were recorded during 18 sample nights. Furthermore, a total of 31 bat species was estimated in the nature reserve and a total of 29 in the macadamia orchards. Clutter edge and open-air feeding bat species were generally more active than clutter-feeding bats. Bat activity was almost equal when comparing between the two orchard edges, but differences were observed when looking at guild and species level. At the human-modified edge, activity of open-air feeding species was higher than at the natural orchard edge compared to other feeding guilds. Clutter edge activity was higher at the natural edges, while open-air activity was lower here. The clutter foraging guild was the rarest feeding guild in both study areas. However, this foraging guild occurred significantly more frequent in the nature reserve than in the orchards. Clutter edge species were identified to rely more on natural orchard edges, while open-air feeding bat species preferred the human-modified edges. Species richness, diversity, and activity were significantly higher in the nature reserve than in the macadamia orchards. And the bat community composition and activity clearly showed a near exclusion of clutter-feeding species from the monoculture-dominated simplified macadamia landscapes. These findings are supported by similar results from studies in intensive agricultural systems such as sugarcane monoculture, which found a near absence of clutter-feeding species. Aside from the preference of this guild for dense cluttered vegetation, their absence could also be due to farm management practices. A study in Britain compared bat activity on organic farms to that on conventional farms, and has reported that clutter-feeding Rhinolophus species were only active on organic farms. Macadamia orchards are extensively sprayed with pesticides, which may deter sensitive species like the Rhinolophus. Other findings showed that bat activity patterns are affected by structural simplification. In highly transformed rural settlements and croplands directly east of our Levubu study area, Rhinolophus species are completely absent according to the study of one of our colleagues. While bat activity was not affected by the orchard edges, clutter edge feeding species were more active at natural edges. And pest control services by bats and birds were previously found to be higher at these edges compared to the human-modified edges. This means that clutter edge feeding species may potentially contribute more to these biocontrol effects on crop yield and quality, but could be facing similar activity declines to clutter-feeding bat species, with the ongoing removal of natural vegetation in order to create more croplands. In South Africa, this is at the moment very common in the lucrative macadamia industry. This can result in widespread landscape homogenization, which severely threatens bat diversity and their ecosystem services. Our regional comparison supports this prediction, showing significant differences in total bat activity and feeding guild activity between the nature reserve and the macadamia orchards. Guild-specific preferences in bat communities in macadamia orchards are likely linked to greater macadamia pest control services close to natural edges. Decreased biocontrol may in turn result in an increased need for chemical control and pesticide application, which would result in an increase in production costs as well as further pressure on remaining ecosystem services, for example by predatory arthropods. In conclusion, heterogeneous agricultural landscapes can support a high bat biodiversity, in particular if they are located close to natural areas such as nature reserves, as seen for our studied landscape in South Africa. However, under current levels of land use change, these agricultural landscapes are increasingly homogenized by growing crop monocultures at the expense of natural habitat. Specialist species like the horseshoe bats have already been near excluded and their services lost, but even generalist species are likely to be threatened if food resources and roosting sites become scarce. In turn, ecosystem services like pest suppression may become likewise highly threatened. Biodiversity loss and agricultural intensification are threatening the sustainability of crop production. Our results highlight the importance of heterogeneous landscapes in and around macadamia orchards, which provide connectivity, foraging and roosting sites through natural and semi-natural edge vegetation, and corridors to promote the diversity of bat species and their ecosystem services. So thank you very much for your interest in my talk, and I am looking forward to your questions now.